Imagine a universe where life thrives in the most extreme environments. From boiling heat to freezing cold, toxic atmospheres to crushing pressures. What would life look like if it existed on the planets of our solar system? Let's explore the fascinating possibilities. Mercury, the planet closest to the Sun, endures some of the harshest conditions in the solar system. Daytime temperatures can soar to 430 degrees Celsius, while nights plunge to a frigid minus 180 degrees Celsius. There's no atmosphere to shield against intense solar radiation. Life on Mercury, if it existed, would have to survive these extreme temperature swings. Perhaps creatures would live underground, avoiding the radiation and insulating themselves from the heat and cold. They might have thick, heat-resistant shells and could enter a hibernation-like state during the planet's long nights, conserving energy harvested from the sun during the day. Next, we journey to Venus, a planet with surface temperatures hot enough to melt lead, a crushing atmospheric pressure 92 times that of Earth, and clouds of sulfuric acid. But far above the hellish surface, at around 50 kilometers in the atmosphere, conditions are surprisingly Earth-like. If life exists here, it might be microbial, floating in the acidic clouds. These airborne organisms could metabolize chemicals such as sulfur and may protect themselves with a biofilm-like layer to withstand the acidic environment. Mars, often called the Red Planet, is a cold desert world. Its thin atmosphere is mostly carbon dioxide. Surface temperatures average minus 60 degrees. With no magnetic field to protect it, the planet is bathed in harmful radiation. If life exists on Mars, it would likely be microbial and hidden underground, shielded from radiation. These organisms might feed on minerals or chemicals in the Martian soil, like iron or hydrogen, resembling some of Earth's toughest extremophiles found in Arctic or desert environments. Jupiter, the gas giant, has no solid surface. Its atmosphere is made of hydrogen and helium, dominated by violent storms like the Great Red Spot. Temperatures vary greatly, and the winds are fierce. If life could exist here, it might be in the form of floating creatures, drifting in the upper atmosphere. Picture giant, jellyfish-like organisms with balloon-like structures to stay buoyant, feeding on the rich chemical compounds in the clouds. They might even harness energy from the planet's frequent lightning storms or turbulent winds. Saturn, another gas giant, shares similarities with Jupiter. It's extremely cold, with an average temperature of around minus 140 degrees Celsius. But its atmosphere is less chaotic. Like on Jupiter, life on Saturn could take the form of floating, gas-filled organisms. These beings would drift through the upper clouds, capturing energy from the faint sunlight or feeding on the hydrocarbons in the atmosphere, maintaining buoyancy through complex chemical reactions. Further from the Sun, Uranus is an ice giant. It has a frigid atmosphere composed of hydrogen, helium, and methane, with temperatures plunging to minus 224 degrees Celsius. Uranus also tilts on its side, causing extreme seasonal variations. Any life here would need to survive in deep layers where pressures and temperatures are less hostile. These creatures might be slow metabolizing, simple organisms, feeding on chemical reactions between hydrogen and methane, or possibly drawing energy from geothermal heat deep within the planet. Neptune, similar to Uranus, is another icy world with incredibly high winds, and freezing temperatures. The atmosphere, rich in hydrogen, helium, and methane, creates a cold and dynamic environment. Life on Neptune, if it exists, could resemble slow-moving, cold-adapted creatures. Floating through the atmosphere, they might feed on methane gases, surviving on minimal energy. Alternatively, life could exist deep within the planet, near a rocky core where geothermal heat provides warmth and energy. Conclusion: the idea of life on other worlds is no longer confined to science fiction. From underground microbes on Mars to balloon-like creatures floating in the gas giants, the possibilities are endless. Each planet offers its own challenges, but life, in its infinite adaptability, just might find a way. If you enjoyed this video, please like and subscribe for more exploratory content.